Today we're going to learn about constructing rational equations. Let's say we have a problem like this. Construct a rational equation if the function has a vertical asymptote at x is equal to 5 and x is equal to 7, holes at x is equal to 3 and x-intercepts at 1, 0. So before we get started, let's remember how to write a rational equation. So f of x, function of x, is equal to, in the numerator we have x minus the holes, however many there are, times x minus the x-intercept, however many there are, over x minus the holes, however many there are, times x minus the vertical asymptotes, however many there are, plus the horizontal asymptote. So, as we can see, in the numerator, we always have the holes, if there are any holes, times the x-intercept. So in the numerator, the x-intercept only shows up in the numerator. And in the denominator, the vertical asymptote only shows up in the denominator. However, as you can see, the holes show up in both the numerator and the denominator. And at the end, we add our horizontal asymptote. So now let's go in and plug our numbers. So f of x is equal to x minus the whole, so x minus 3. There's only one whole, so now we're going to move on to x-intercepts times x minus 1. As we can see, there's only one x-intercept, so we're just going to move on to the denominator, because now the numerator is complete. So in the denominator, because the holes show up in the numerator and the denominator, we also have to put x minus 3 in the denominator, times the vertical asymptotes, which are at x is equal to 5 and x is equal to 7. So x minus 5 times x minus 7. As we can see, we have no horizontal asymptote. So this is our rational equation. It is f of x is equal to x minus 3 times x minus 1 over x minus 3 times x minus 5 times x minus 7.